So today we are going to talk about chapter 4, analysis of variance. If you see this figure, you can see that we have three groups and they are normally distributed. So suppose you have three different data which came from normal distribution, and you want to compare the mean of these three data. So the method we are going to use in order to compare is called analysis of variance. So the learning outcome for chapter 4 is by the end of this session you should be able to compare population mean of more than two groups using a method called analysis of variance. In shortcut it's called Anova. So like previously, we talk about two different company A and company B, and we want to compare the lifetime of light bulbs of two different company. Now we have extended this into three companies. Suppose you want to compare the mean lifetime of light bulbs of three companies or three brands, company A, company B, company C. So you are asked to see whether there is a difference between the mean of these three companies or they are equal in their means. So in order to do that, we took a sample from company A, sample in company B, and sample of company C light bulbs. So when we take a sample and we calculate the mean, then we are calculating X bar. And same thing here, and same thing for company C. Now, when we compare, we have to use a method called hypothesis testing. There are 6 procedures in order to reach the conclusion by the end of the hypothesis testing. So the beginning step is you have to define what you are doing. So you have to define or state the null hypothesis. In the null hypothesis, we always state that the mean of the three companies or the mean of two companies, as we did before, are equal. So same thing here, for analysis of variance, we have to state the null hypothesis. We will say that the mean of three population or three companies are equal. In alternative, we write it in different way in analysis of variance. In alternative, we write that at least one of the company is different from others. Okay, so at least one of the mean is different. We don't write that mu1 is not equal to mu2 or not equal to mu3. We just need to mention that at least one of them is different. Okay, if you observe that still in the null hypothesis, we are talking about the mean. We are comparing the mean, whether they are equal or at least one of them is different. But why we call this as analysis of variance? Because we are going to use the variance in order to compare the mean between more than two population. More than two population analysis is variance is used. So one-way analysis of variance, or what we call it as one-way Anova, is used to test the claim that three or more population means are equal or at least one of them is different. So this is exactly what you have done in t-test, but this is an extension of two independent sample t-test. The response variable, or y, is the variable that you are going to compare, and the factor variable is a categorical variable. It's just you are going to categorize your data into different categories. Let's say that we have k different groups, so we will have one factor and we will have a response variable which we are going to compare. So one-way Anova is called one way because we have defined our data as one factor. For example, in previous example, we have compared only the brand of the light bulbs. So the factor is only one. These light bulbs are categorized by brand or by company. So the factor is only one, which is company or the brand, whatever we can say. Now, so each value is classified in exactly one way or one factor. Example include like you're comparing between gender, so gender is considered as a factor. Sometimes you have to compare between female and male, but this is only two groups. You can extend it to more, race or political party, color, like that. That is called categorical variable, and that's called factor variable. What are the conditions in order to use analysis of variance? You must ensure that the sample are randomly selected, and the variance of, you have to assume or test the variance are equaled, and the residual or the error term between the data are normally distributed. Okay, usually in your problem it's already given that these assumptions are already valid. So what are the null and alternative hypotheses when you are using analysis of variance? In the null hypothesis, you say that the mean are equal, like I have mentioned, mu1 is equal to mu2 is equal to mu3 if you have 3 groups, up to mu k if you have k groups. Okay. Alternative hypothesis, you say that at least one of the means is different. So the Anova doesn't test one mean is less than another. It measures whether they are equal or at least one is different. Now this is an example where we have to use Anova. Suppose you have five systems, and we want to compare the emission rate or emission value in hydrocarbon part per million for each systems. So we have taken a sample of 4 in system 1, and then a sample of 4 in system 2, similarly in system 3, system 4, and system 5. We want to see whether there is a difference between the 5 systems in the emission rate or not. So the question is, do the system emission differ at 5% of level of significance? So what you have done previously in testing the hypothesis, it is exactly same what you are going to do in Anova, but you are going to use different distribution because you are going to use a variance in order to compare the population mean between the 5 systems. So here we have 5 systems. So more than 2 groups, whenever you're comparing, you must use Anova. So what are the steps required for Anova? Step number 1, you have to define your null hypothesis as you did before, your H0. You state that all the systems has equal mean. So population mean for system 1 is equal to the population mean for system 2 up to system 5. Okay. In alternative hypothesis or in H1, you say that at least one system has different emission mean than others. Okay, so at least one system has different mean emission than others. That is your step 1. Step 2, you have to select the level of significance, like what we have done previously in chapter 3. We have to do the same thing. So here it's already mentioned that the level of significance in this test is 5%. So you might make an error of 5% in rejecting the null hypothesis where it is 2. Now step 3, we usually decide which distribution to use. Now when you have more than 2 groups and you are comparing the population mean, and you know that your population come from normal distribution, then so when you are comparing more than 2 groups, you have to use F distribution, because only F distribution use a ratio of two sample variance. So because it's called analysis of variance, so you're going to use the variance in order to reach your conclusion. So variance is used only in F distribution, okay, F test statistic. So what is the test statistic that you are going to use? It's called F. It's one of the distribution which you use to compare variance, and F is equal to MSB over MSW. So what is MSB? First of all, MSB is called mean square error between the groups. This we will define later on in detail. And what is MSB? It is the sum of square of between groups divided by degree of freedom of between groups. This all again I am going to explain it in detail. And what is MSW? MSW is called mean square error within a group. So you should know the difference between groups and within group. So MSW is equal to again sum of square of within group divided by degree of freedom within group. So these two equations are used in order to compute the F test statistic. Okay, so F test statistic is computed by MSB over MSW, and that is calculated using these two formulas. We will understand this more in next slides. So step 4, in order to compute the test statistic, before you compute these, first thing you have to do to compute the test statistic, you have to get the summary of your data. Since we have 5 systems, so you must compute the mean of each system. So the sample mean is computed by the summation of x divided by n. So what we mean by the summation of x divided by n? It means we have to sum all the values in system 1 and divide it by 4. So we reach to this number. Again, for system 2, we have to add these values and divide it by 4. Similarly for system 3, 4, and 5. So these are the sample mean. These are called X bar. You can do that by using Excel. I will show you now. So this is a sample variance. If you don't want to use Excel, you can use this formula. Summation, each value in each system you subtract it from the mean and you divide it by n-1. Why n-1? This is called degree of freedom. Okay, because we are computing a sample variance. Once you have done the sample variance, you can compute the standard deviation and get the answer. So how we compute these using Excel? So in order to compute the sample mean, sample variance, standard deviation for 5 systems, we use Excel. The function for sample mean is average, and we have to select only the values of emissions. Don't select the system 1 because this is only the system. I can also delete this if I want. And similarly, you can do for system 2, or you can drag. Now, sample variance, again, the function is used VAR. You have 2 different functions for variance. We have only sample, so we have to use variance for the sample, the second one. We select this data. Remember that you should not select the first, because this is only the sample, the system number. Okay, then we have to drag for the rest. Again, standard deviation is computed by the square root. So square root of variance. Then we can drag all these.